Welcome to our exploration of an expanding universe, a vast and ever-expanding expanse that has revolutionized our understanding of the cosmos. Since the Big Bang, space itself has been stretching, carrying galaxies along for the ride. It's a mind-boggling concept, leading to an intriguing question. If the universe is expanding, does everything within it expand as well? Imagine a universe where not just galaxies drift apart, but our planet, our homes, and even we ourselves are growing larger. The very idea of everything expanding might seem like something out of a science fiction novel. We don't see our houses getting bigger or the Earth swelling up. So, how can the universe be expanding while everything around us appears to remain the same? The answer lies in understanding the difference between cosmic expansion on a grand scale and the local forces that govern our everyday lives. The expansion of the universe is a phenomenon that operates on vast cosmological scales. The expansion of the universe is a profound concept that has reshaped our understanding of the cosmos. It's not that galaxies are moving through space, rather space itself is expanding, carrying galaxies along with it. Imagine dots on a balloon that's being inflated. As the balloon expands, the dots move farther apart, not because they're moving across the surface, but because the surface itself is stretching. Similarly, galaxies are like those dots on the expanding balloon, drifting apart as the fabric of space stretches. The farther apart two galaxies are, the faster they appear to recede from each other. This observation, based on the redshift of light from distant galaxies, provides strong evidence for the expansion of the universe. It's important to note that this expansion is not a force. It's an inherent property of space-time itself. The universe is not expanding into anything. Space itself is simply growing larger. This expansion affects the larger scales of the universe, the vast distances between galaxies and clusters of galaxies. While the universe is expanding on a cosmic scale, local forces play a dominant role in holding things together on smaller scales. Gravity is the force that attracts objects with mass, keeping planets in orbit around stars and stars bound together in galaxies. It's the force that keeps our feet firmly planted on the ground and prevents the Earth from disintegrating. Electromagnetism is another fundamental force that governs the interactions between electrically charged particles. It's responsible for the bonds between atoms and molecules, giving structure to matter and holding everyday objects together. From the chair you're sitting on to the device you're reading this on, electromagnetism is at work, maintaining the integrity of these objects. These local forces are much stronger than the expansion of the universe on the scales of planets, stars, and everyday objects. Gravity and electromagnetism effectively counteract the expansion, ensuring that these objects remain bound together. The expansion of the universe is simply too weak to overcome these local forces. Let's indulge in a thought experiment and imagine a hypothetical scenario where human-scale objects were subject to the expansion of the universe. If our bodies were to expand at the same rate as the universe, we wouldn't even notice it. The expansion is so slow that the change in our size would be imperceptible over a human lifetime. Imagine waking up one morning and finding that everything around you, including yourself, has grown slightly larger. Your house, your car, even the Earth itself would have expanded. But since everything expanded at the same rate, the relative proportions would remain the same. Your house would still appear the same size relative to you, and the Earth would still feel just as solid beneath your feet. The very notion of everything expanding uniformly leads to a paradoxical situation. If everything, including our measuring instruments, were to expand at the same rate, we would have no way of detecting the expansion. It would be as if the universe were playing a cosmic trick on us, expanding everything while leaving us none the wiser. The stability of atoms. One of the key reasons why everyday objects don't expand with the universe is the stability of atoms. Atoms are the building blocks of matter, and they are held together by the strong electromagnetic forces between the positively charged nucleus and the negatively charged electrons. These forces are far stronger than the expansion of the universe on atomic scales. The electrons in an atom occupy specific energy levels, and the distances between these levels are determined by the electromagnetic force. The expansion of the universe is simply too weak to affect these energy levels or the distances between them. As a result, atoms maintain their size and structure, ensuring that the matter they make up remains stable. The stability of atoms is crucial for the existence of everything we know. It's the foundation of chemistry, biology, and all the processes that govern life and the universe around us. Without the stability of atoms, the world as we know it would simply fall apart. The Earth, our home planet, is a massive object held together by the strong force of gravity. The gravitational attraction between the Earth's mass and everything on it is far greater than the expansion of the universe on this scale. As a result, the Earth remains a bound object, its size and shape unaffected by the cosmic expansion. The expansion of the universe is simply too weak to overcome the Earth's gravity. It's like trying to pull apart a rock with a tiny rubber band. The rubber band might stretch, but it won't be able to overcome the rock's internal strength. Similarly, the expansion of the universe might stretch the fabric of space, but it won't be able to pull apart the Earth. The Earth's gravity not only holds the planet together, but also keeps us firmly grounded. It's the reason why objects fall to the ground when we drop them and why we don't float off into space. Gravity is a fundamental force that governs our everyday lives, ensuring that we remain anchored to our planet. While local forces dominate on the scales of planets, stars, and everyday objects, the universe as a whole is unbound by these forces. The expansion of the universe operates on vast cosmological scales, where the distances between galaxies are so great that gravity and electromagnetism are no longer the dominant forces. On these cosmic scales, the expansion of the universe takes over, stretching the fabric of space and carrying galaxies along with it. This expansion is not a force, but an inherent property of space-time itself. It's the reason why distant galaxies appear to be receding from us, and the farther away they are, the faster they seem to be moving. The unbound nature of the universe has profound implications for our understanding of the cosmos. It suggests that the universe will continue to expand indefinitely, becoming increasingly cold and dark as galaxies drift farther and farther apart. The ultimate fate of the universe is still a subject of debate among cosmologists, but the expansion plays a crucial role in shaping its destiny. Understanding the expansion of the universe requires appreciating the different scales at play. From the tiny world of atoms to the vast expanse of galaxies, the universe operates under different rules depending on the scale. At the atomic level, electromagnetism reigns supreme, holding atoms together and giving structure to matter. On the planetary and stellar scale, gravity takes over, keeping planets in orbit around stars and stars bound together in galaxies. These local forces are much stronger than the expansion of the universe on these scales. However, on the grandest scales of the universe, where distances between galaxies are vast, the expansion takes over. Gravity and electromagnetism become weaker with distance, while the expansion of space itself continues to stretch the fabric of the cosmos. We live in a universe that is both expanding and bound together by local forces. The expansion of the universe is a cosmic phenomenon that operates on vast scales, stretching the fabric of space and carrying galaxies along with it. However, on smaller scales, gravity and electromagnetism hold things together, ensuring that planets, stars, and everyday objects maintain their size and structure. The expansion of the universe doesn't affect our daily lives because the local forces that govern our world are far stronger than the expansion on these scales. We don't see our houses getting bigger or the Earth swelling up because gravity and electromagnetism effectively counteract the expansion. Understanding the interplay between cosmic expansion and local forces is crucial for comprehending the nature of the universe. It reveals a universe that is both dynamic and stable, a cosmos where galaxies drift apart while the world around us remains intact.